you can remind me like, hey, we're having a little trouble with this one. Did I do the one about area of the weeds or something?
Yes.
Okay. Set that up. It was okay?
Mm-hmm.
Yeah? Ms. Aver's like, oh yeah, okay. All right. I got her attention, so we're good. We're doing good. So why don't we just do one of these other ones that you might see in the future, okay? All right. So I think, ooh, that's a good one, right? Now you guys have all the way up to 2015, yes? Mm-hmm. Sandy gauge and all that stuff? Oh, this is a good one.
Can we do one with sine and cosine?
Yes, I was thinking the same thing. How about this one? I put a little blue sticker, a blue sticky note to it. All right, let's try this one out. Our minds thinking like Stephen Hawking, yes? Let's try this one. Number May, June, and I'll write it along with you instead of just like, you know, be one of those lazy teachers or whatever. Maybe I'm even more lazy because I'm sitting down and talking fast. All right, so can just focus. It's focusing on the dirt, dust, and debris from the lens, right? Because of the resolution. But okay, so this one is, let's say, May, June, 2014, and then dash 33. How's that one? I'll wait till you guys get there, and that's number 5. Looks really monstrous. Raw. It's a 7-pointer.
It's just one part.
Yeah, I think it's just one thing. It says, you guys, if you tell me to do that, right? It's like that 2 cosine square deal?
Yes.
Yes. Okay. Not bad? Everybody okay? Mm-hmm. Okay, good. All right, so, all right, those ladies said they're okay? Okay, all right. So here we go. So I'm going to copy it down so you see it. All right, you can see my fat fingers and so on. I used to play piano. I still do sometimes. I went over my friend, my wife's doctor's friends, you know, like, oh, you know, doctors know doctors, right, Ryan? And so, yeah, that's right. So I'm over there and they have this grand piano, and I was like doing this, and she, so my wife doesn't see it, you know, it's like it had the stick up and so on, you know, and so you can see the carpet. I'll catch it. And the big thing was, I was like, as long as I get out of this house, right, for this mandatory fund, MFO's mandatory family obligation fund obligation, so I don't have to play the piano for these women. That's what I was saying. But I was fortunate that I kept on doing the blocking, you know. Like, you don't see nothing in this room, Ryan. You don't see nothing in this room. Okay. All right, here we go. So you got cosine theta, dx dt, right? Mm-hmm. Dx d theta, excuse me, equals the square root of this radicand, right? And you don't need to use the parentheses here. It's understood as 2x plus 1. But we'll be consistent, okay? Mm-hmm. All right, so far, is that copyright? Okay, what's it want? It gives us some initial conditions, which are x equals what?
0.
Yeah. Theta is 1 pi over 4, 1/4 pi. I agree. And then it says, hey, solve it in terms of x. So solve in terms of x. So you know what's going on, right? You know, x d theta, something to that effect, right? Mm-hmm. X d theta. All right, or x theta. All right. So I'll write this here. That's what it wants. And you guys are pretty smart in this one. All right, here we go. Breathe in, breathe out. Okay, talk to me. What's the first step?
Separate the variables.
SOVs, SOLs, SOSs, right? Billy's not here. She likes to say SOL. Okay? All right, so SOVs, right? So, you see the dx here? Yeah, you see the d theta there? I always say to make life easy for yourself, get these in the numerator, right? So, this guy goes here, and as well as the cosine's going to follow it too, right? And then this radical is going to come to the other side. Everybody okay so far? Mm-hmm. All right, so do you want to just write the finished product before we integrate?
Yeah.
Okay, keep the 2 here. You know, it really doesn't matter where the 2 is, but they kept it on this side, it doesn't matter. So here we go. We got 2, and remember, it's going to be what? There's going to be a dx there, right? Yeah. And I'm going to lower this a little bit, okay, so you can see it? Yeah. So we're going to have what?
2.
Thank you, 2 over what, ladies and gentlemen? The square root, right? Because we're dividing by this whole thing. Okay.
Square root of 2x plus 1.
Yes, correct. 2x plus 1. And they like to put the dx on the side. That's just common to do it. You don't have to. You put it in the numerator. But they like to put it on the side. It doesn't matter, okay? Equals what, ladies and gentlemen?
D theta over cosine.
There we go. Ladies are on it as usual, okay? D theta cosine, 1 over cosine. They do it this way, right? Cosine squared theta. Is that okay? Okay. All right, we separated the stuff, right? The Hatfields with the Hatfields, the McCoys and the McCoys, so to speak. Yeah. You remember the Hatfields and McCoys? the farmers, and not farmers, those rebel people that fought in Virginia.
Yeah.
Yeah, the two families. Okay. You know, like the ones in what is it? Romeo and Juliet? The which ones?
Oh, the Capulets.
And the
Montagues.
Montagues. There we go. All right, showing our literary. We're literate in literacy, okay? All right, in literature. All right, so now what? Next step?
When you,
Snakes, right?
when you integrate,
Yes,
can
ma'am.
you pull that to the front?
Yes, ma'am. You can do that too, or you can put it inside. You're very smart as usual. So Ms. Abear said, hey, pull that constant in front. We're going to integrate this one right here. 1 over. Now I'm going to change this to make this easy, okay? As a radical, as a square root, it can be. Well, it's on the bottom, so yeah, you're ahead of the game as usual, Katie. So it's a 1/2 here, right? And we'll bring that upstairs to make life easy, okay? And now I'm going to make this dx there. Is that okay? Yeah. All right, not bad. And then the little integral, okay, of what? They separate it. You don't have to, but I'll do it just to be cosine squared theta d theta. They like to do this to show you that I have a d whatever with the summa part, which is the integration or the interval. All right, not bad. Pretty good, huh? And Miss Abear's like, hey, wherever there's a constant, you pull that out. I gotta tell that to the younglings in AICE 1 next week. Okay, they're doing all that differential stuff, right? Remember all those days? Yeah.
Mm-hmm.
All right, yeah. Okay, so now we integrate this thing, and I'm gonna pull this upstairs to make this easy. Okay, so we don't have to use any type of arctan and so on. So here we go. So I'm gonna keep the 2 here, right? And equals there. Yeah. And what we're gonna have? So it's gonna be really what? So. Let me do this, just the intermediate step, is that okay?
Yes.
Okay, she's like, yeah, do this. What we got, right? 2x plus 1 to the minus 1/2 dx. Now keep going, right? 2, now I start integrating, right? Now it's going to be add 1, right?
Yeah.
Remember that stuff? Okay, so let's write this portion here. 2x plus 1 to the positive 1/2 divided by what? Well, 2 times is the derivative, right? Times 1/2.
So it's just 1.
So
Is that okay?
2 times 2x plus 1 to the 1/2.
Did I do that right?
Yes.
Yes. Okay. Remember, you add 1 to this negative 1/2 becomes positive 1/2. Check. Then the integral of the dx disappears because we take the integration of, the derivative of the interior, which is that 2, and then, yes?
Yep.
Okay. Oh, you already know. Okay, so I have to,
That's
okay, it's good. It's good. So, all right, be quiet. That's what you need to tell me. All right, now the next thing is I got a cosine squared here, right? And remember, we can use those tables, right?
Yes.
Yeah, that's the biggest thing. When you see this and you see it as a reciprocal, use your tables, okay? And remember, 1 over cosine, just to say this, is what? Secant, right?
Yes.
So 1 over cos squared is secant squared theta, right? Pretty good? Yeah, says me, right? So this is going to be the integration here of secant squared theta, or d theta. Is that okay? All right? It's because you don't have a 1 over cosine, right? Or cosine to the minus 2. You're like, what do you do there, right? You have to do something unique, okay? And that's why I use the integral table, all right? And it's on, I call it the integral table. It's the sheet, yes? Okay. So now what?
What's the integral of that?
What is the integral of secant? How do you know? It says it on the sheet. Okay?
Yeah, it's too lazy.
It's too lazy on the sheet. So I want you guys to write on the side here, like we were talking. I was talking about Fermat. He wrote on the margin. So you write, look at Cambridge CT, Cambridge table. Is that okay?
Yes.
Yeah. See, you're like, what? What is he doing? Magic again? All right. So now we got this guy right here, and he becomes now a good old tangent of theta plus the constant of
Is
integration.
it tangent squared?
Yeah.
No,
Sorry.
tangent.
Okay.
Michael.
We did one that had a secret.
Can I see this chart again?
All right. Secant squared comes out to be tangent, right? Does it?
Yeah.
Okay. You just look at it and substitute and boom. Okay. Are we all right?
Yeah.
Yeah, I'm feeling pretty good. Let's clean this up on the side here.
Why
Okay.
doesn't the left side have the C?
That's a great question, right? Okay, there is a C here, but what they do is this C gets absorbed. It's like this is the bigger. Let's call it the right hand side because most of you are righties, okay? And this side right here, this is the common convention, that on the right-hand side, this is the larger C, and there's a C1 and C2, and this is the big daddy of the C's, and he gets absorbed. Okay? And we move it to the other side, and then we only have one C. Because if we have two C's, we gotta
So it's just implied that there's
Just
a C
do
on
one
C.
C.
just do one C.
Yeah.
I'm sorry. I taught ODEs before. Okay.
I was just curious.
Yeah. Just pretend there's one C. Not pretend, but you know there's one C.
Yeah.
Okay?
Okay.
Oh yeah, just thank you, Chris, for cutting me off. That's good about that, right? Yeah. All right, so this guy right here goes away, right? Because not goes away, but 2 times 1 half is 1. So
Yeah.
that's going to be 2 times that mass, right?
Yes.
Okay. Girls are like, don't ask me. Oh, that's too early. All right, so I'm going to write this in radical form. You don't have to, okay? But I'm going to do it because they did it. You don't have to do this copy step, all right? They're like, we're copying it anyway. So, all right? All right, now, what is this one called? Either this one or this one called. What do we call it?
General solution.
General solution.
Sure.
Okay. Now for you, because you're new to the game here, right? We call that the original what?
Recipe.
Recipe. Okay? You'll never forget it, okay? Yeah. Now we were thinking about food. Remember, yesterday we thought of what? We thought of croissants, right? See, so Sophia brought in croissants, right? She's like, huh?
Have you been to Cheddar's? Have you been
There's a Cheddar's on 192. I haven't been there yet. I have to, so that's something, okay.
They're so
Yeah.
good.
Do you remember there was one kid in Passmore's class, he's really big, Jake,
Jake.
Jake.
has the beard.
He was in
Yeah.
this class, but he transferred out.
Yeah, I missed that. I saw him like down in Melbourne, and he was at Menchie's on 192, and he goes to that I don't know, the church or something or whatever, and he looks like a pastor to me. Okay? That's what he does. He looks like a Quaker pastor. I don't know. And that's what he does. So I just thought that because you guys are Passmore hates him so. But that, it just reminded me down there. That's all. All right. So the food of the day for the original recipe is.
Ooh.
Who's not food? But
I like empanadas.
Oh.
Ooh, those are
Showing your heritage, good. Empanadas. Empanadas are awesome, and they can be also for like cinnamon empanadas, right? Now I miss empanadas. I didn't live in Argentina. I visited Argentina. Empanadas, amps.
Food of the day.
All right, food of the day. We have to do that now. FODs, right? All right. So here we go. Now what? It gave us some stuff up on top, right? Can't see it. It's up here, right?
Yeah.
Gotta plug that stuff in, right? And I'm gonna put it over here on the side like x equals 0, theta. Now we gotta find c, right?
Yes.
Right. So remember, Sophia brought in, she's like, oh God, right? She brought in croissants, right? And then I asked, what's your favorite croissant? And she said, chocolate. She's a winner to me right away. She said one of my favorite foods, chocolate, okay? And so now Ryan's going to make some different type of croissant or an empanada, which would be?
What?
What? You're not, Ryan, you're not getting married.
What am I making?
You're making empanada. What's your favorite empanada if you had one?
Oh, I don't.
All right, what
I don't
else?
do this kind of food.
You don't, oh, really? Any favorite food?
Egg rolls.
Egg rolls. What's your favorite type of, what's in it that makes it your
Pork.
Of course, okay, not the spring ones, right? So he's doing egg rolls, we know what we're doing, okay? All right, back to business. So this here is going to be a 0, right?
Yes.
Okay, so Heine's like, get going. 2 times 2 plus 1 equals tangent. Remember, the theta is going to be what?
Pi over
5
4.
over 4
2 times 0.
plus c. Okay?
Yeah.
Get on with the business.
Is it 0?
I don't know. Not yet. You're too ahead of me.
No, x equals 0.
Yeah.
Yeah.
Oh, 0.
Yeah.
Thank you. Thank you. So 2 times 0 is 0.
Zero.
Plus 1 is 1. The square root of 1 is 1 times 2
Two.
is
2.
2.
2.
What's the tan of pi?
And what's the tan of 45 degrees?
I don't know.
No.
1.
1. Because it's a right isosceles triangle, right?
Because
One,
the
one,
sine and the
three.
cosine are the same.
That's another way of thinking
So
about it.
1
And if you didn't know, you plug it in,
That's
okay?
how I remember.
I know it because it's on the 1, 1, root 2 triangle. Okay? You remember this stuff? If you wanted to know, you're getting me now really thinking about it. This is 1, this is 1, this is root 2. And
Yeah.
theta is the inscribed angle. So the tangent is opposite over adjacent, so it's 1 over 1, right? So these sides must be equal because the angles are acute as well as equal. It's called a right isosceles. So hence these sides are also equal. All right? So we know, just give it over. So it's just 1, right?
Yes.
Yes.
Plus C.
So C
C
equals 1.
equals 1.
Woo!
Welcome back, Ryan. Okay? All right, not bad. So now we plug in the pork. for you, and the chocolate, Miss Sophia, and some cinnamon perhaps for a good treat for an empanada, okay? I like cinnamon with the empanadas, minus the meat, so if it's a dessert. Dolces? Is it dolces?
I've never had them with cinnamon.
We never had it.
No, I've always had them with meat.
With meat. You can have them with anything, but I was in Argentina for a couple weeks, so yeah, they helped this gringo out, okay? Yeah. All right? All right, so here we go. So C's 1. So what's the particular solution? It's going to be 2. Square root of this stuff, right?
2x plus
Okay, equals tangent of theta plus what? 1.
Yeah.
Yay.
This is our particular
Solution.
solution.
Oh, we have to get it.
No, it's-
That's a secret sauce.
So
All right, hold on.
for x.
Yeah, well, you're ahead of the game as usual. Oh, man. Don't be gazelles here, right? Gazelles, right? Now, the last part it asked for was solve
X and-
for x in
yeah.
terms of theta, right? So once x on one side, theta on the other side. Okay? Doesn't sound that bad, right?
Mr. Murmer,
Yes, sir.
so can't you square both sides to get rid of the, or first divide by 2 and then square both
Yeah, I
sides?
divide both sides by 2.
Yeah, I should do that.
Yeah, and then take the square root, I guess, and then subtract 1, etc. Right? I bet that a little better? Okay, here we go. So, everybody okay? I'm going to switch the page here, right?
Yep.
Yep, just get going. Get going. These guys are slow. Okay, so here we go. 2x plus 1, right? Oh, can't see it. Sorry there. And to all of you two people, all right, equals tangent theta plus 1. Remember, here we go on the little ledger, solve for x. Why? Because we want the points, and we want to get out of Calc 1 for college. Okay? So, first step is divide by 2, I guess, right? All right, here we go. Divide by 2 here. Divide by 2 there. Not bad. Square root of, how are we doing so far, okay? 2x plus 1. I'm not bad, actually. I'm thinking of so this is 1/2 of tan. I can write it this way if I wanted to, right? Of theta plus 1/2. You can write it another way if you wish. You don't have to, right? And I can factor out a half, like I didn't just do that anyway, right? I can do that too. So I'll clean this up, okay? So this is going to be tan theta plus 1 over 2. Is that okay? I did that anyway, right? Now I'm going to square this, and I'm going to square this, right? That means I square this. Oh, whatever, right? So far so good?
Yep.
So here we go. We got 2x plus 1 equals this stuff here. That means I can square the bottom and bring it out, couldn't I? Yes, you can. That means it's going to be 1/4 times that stuff inside the numerator, tan theta plus 1. Now it's nothing to it, right? Then I subtract 1 and then divide by 2. Why don't we just give the last portion of it? They got 1/8 of this thing. That's a square right there. And theta plus 1 squared minus 1/2. Everybody okay? It's just a little algebra. Guys, if you get down to here, you're in great shape, okay? Or even here, or wherever. Mr. Evans.
So they just foiled out that tan theta plus 1 over 2?
You foil it out? You could, but why? They just want to buy x, right? Get x by itself. Now it's really a literal equation, right? That means you just solve for the letter they want, right? So if they give you Celsius, they want Fahrenheit, get F by itself. Or if they have Kelvin and they want C by itself, then you of course add, you subtract 273 from both sides, I think, right? Yeah. It's really 273.153, but who cares, right? And if you really want to know what because Mr. Up was talking about what's the big deal? Well, absolute zeros are around 459 degrees, minus 459 degrees Fahrenheit.
I knew that.
I do too. Okay. Yeah. So now we're in the same league. All right. Any questions? All right. Not bad. Michael, okay? Not a bad one, huh? How much time left? 1 billion minutes?
A good amount.
We got a decent amount of time.
Yeah.
All right. So I just want you to be prepared for that stuff, right? Oh, this is a good one too. Oh, me too. All right. All right. So I'm ready. I prepared, guys. Okay. And so, does anyone have? Okay. So I can switch. Ooh, that's a good one. Ooh, I like that one. Okay. So she's getting her stuff out. So that means it's serious. and Ms. Abear. Any questions on this one? Pretty good? If you need to see it, I have it. You can just take it and take it with you, and you're good as gold. Okay? What you got? Ms. Abear. You got a question on homework?
No, can I just check what I'm on?
Can you want to check?
Like, do you have the answer?
Yeah, check with me 5 minutes later. 5 minutes before class. All right? All right, no questions on this guy. Pretty good? So I'm just exposing you to the sines and cosines. You want to try another one? And then we can stop. Stop me 5 minutes prior. Is that okay? So you know, like, oh, this, come on, bring it on, you know, that type of stuff. That's what I like to see, you know, you guys get some super confidence. All right. Okay, so I saw this one here. Hopefully my stuff's not mixed up. Yeah, it's mixed up. All right. I was talking about law school in the other class. My friend was a law student. Ooh, yeah.
Do you want to do a 10-pointer?
A 10-pointer? Let me hear it. Which one?
October, November 2013, number 10.
Number 10. Yeah, 10 banger. Maybe I marked it, I think, okay? Oh, that one.
It's funny. It's number 10.
Is it the graph?
Yeah.
Oh,
Yeah, that weird.
the ladies
little
read my
squiggly thing.
mind. All right, here we go, right?
I literally haven't used
All
it
right.
in like a week.
So how much time left?
We've got like
Like
15 minutes.
15 minutes.
All right, so we can at least set this up. This is a beast, right?
Which one is this?
If I ask this one, it's extra credit, okay? This
October,
is
November
awesome.
2013, 33, number 10.
Goodness.
Oh,
Looks like
all right,
this is
so
the graph.
I'm gonna just show a cheesy graph here, and then we'll continue on from there, okay?
Okay.
All right, rock and roll. You got it on the side.
Yes.
Okay. All right, Miss Hooper, use that correctly. Never. Oh, I can't say that. It's on.
Number 10.
All right. So this is number 10. Okay, number 10. Thanks, like 10 banger. I like that. She goes for the gold here, okay? Or the platinum. 2013.
Yeah.
33. This is 10 pesos. Pesos, right?
Peso.
Pesos. All right. In Spanish class, get that with a ruler. All right. So I'm just going to write the equation, okay? And you see the graph, right? And
Yeah.
then we'll write some good stuff on the side, okay? Ooh, this isn't bad. But it looks ugly, right? It looks like my, like some, you know, TV dinner problem here that I'm feeling later on, okay? 4, yeah, y 3 plus 1 cos squared x. Okay, did I copy it right? Yeah. All right, so first step,
Separate variables.
separate variables, check. Okay, yep. So the y's with the y's with the dy's, and the cosines with x's with the dx's, okay? Not bad? So I'm going to move the dx, I'm just going to show this, the dx to the other side, and the y plus 1 to the other side as well, okay? Y to the cube plus 1 to the other side.
Yeah.
So let's just clean it up. We're going to have what? And the 3y's already there too, right? You're going to need this 3y squared with the u du, okay? That's just or y dy, right? You're going to need that portion to do the integration. I'll just do it, right? So we got 3y squared over this thing, right? Y to the third plus 1. Well, that's 1.
Yeah.
Then remember, I like to put the dy here, and you know, if you have Mrs. K, you see it, I'll put money that she's been trained like I have. It's just a math thing that they like to put the dy's separately. It's just a nuance thing, but okay. And if the dy's by itself, we always put it in the numerator and then we move it, but that's just, you know, massaging it, okay? 4 cos squared x dx. How we doing, ladies and germs? George Burns would say that. You know he lived to like 95 years old?
Who?
George Burns, he was a comedian. He was like one of those, he told you a joke and then he told you the punchline, you know? See, if I see you walking on the sidewalk, I'll walk on the other side. You know, he had like just the slapstick humor.
Yeah.
Yeah. All right, separated? Yep. Okay. His is his, hers is hers, right? All right, next.
Integrate.
Integrate. So I'm just going to get here, whoop, and for you, whoop, right? Now, Ms. Abear's like, hey, you could pull that out. Yes, I could, but you know something's going to happen here, right?
Yeah.
Uh-huh.
Mr. Murmer?
Yes, sir.
So it has to be a du over u?
Is it just,
It's
Uh,
a DU. It is.
What?
It's
It is,
DU
okay.
for you.
So,
Okay.
so we're good to go.
Yes, we're good to go, right? We'll get to you in a second, okay? Now, can I write over here on the sides of some stuff?
is this like
It's a
a
DU over U.
Right?
DU.
So remember, right? We're going to do some stuff here, okay?
ln.
Yes.
Yeah.
All right. So you say to yourself, you might do it differently. This is how I've done it for 100 years. y to the third plus 1, right?
Yes.
And then du equals, see, I have to have that derivative portion to do this cubic. 3y squared, yay!
Yep.
Yay, there we go. So this disappears, right?
Yeah.
Then it's times the derivative of the interior if I'm right, or yeah, maybe, no, it gets absorbed. All of that gets absorbed, okay? So on this side, he's absolutely right. It's going to be the natural log of what?
Y cubed plus 1.
That's it, right? Yeah, that's it. Because that gets absorbed from the du, okay? See, I did that cheesy looking circle here?
Yep.
You always look for your dy, or we always say the u and the du, okay? And if I don't finish this, stop me 5 minutes prior, okay? So like, okay, we got it, it's going to go away, right? All right, next vector. So the next thing I look at is this guy on the other side, right? So I got one side. Now they do this thing over here, right?
Yes.
Well, the first thing they say is cosine squared something, right?
Yes.
What can I do with a cosine squared x? Remember, he's in the numerator now, right? So I can't use
Yeah.
that reciprocal property.
You can make it cosine times cosine.
Yes, you can. Okay.
What is cosine?
Is there-
Remember, there's 3 things for cosine, right?
Is there?
Oh,
Yes, Nick.
is it the identities? Like,
Yeah, it's a straight. I call it a straight identity, right?
yeah.
And Michael, is it anywhere on there? Cosine can be squared x can be put into some other form to make life easy.
Oh, it's 1 plus 1 minus
1 minus sine squared.
Yeah, you can do 1 minus
Why
sine.
would you do that?
Yeah, that's not going to
I wouldn't do
get
that
us
one
anywhere.
because you want to get rid of the squared property, right? And to be
Right.
it disappeared,
Yeah.
right?
Wouldn't you do like cosine times cosine?
You would do what?
No.
Cosine.
No, here.
What can you integrate? You can integrate
All right.
regular
So
cosine.
we have cosine squared x, right?
Uh-huh.
Yeah.
Yeah.
How can we change that into something?
Cosine times cosine.
Well, we have 4, right? We have 4 cosine squared x, right? Because there's
Yeah.
a 4 right there, right? So we're going to manipulate this in some fashion. Well, we know that this in here, this cosine squared x, I believe can be changed into what? A double angle, right? A 2 theta or 2x? Is it on the sheet, Michael? Anything
Can
on
we
there?
just take the square? You can't do that. Take the square root.
Nothing on there for double angles? Because we want to get rid of this power, right? Nothing on there for double, Mr. Epler?
So you can't integrate it if it's cosine squared x, but if it's cosine of x, then you could go with integral.
Yeah, then you can just change the whatever, sign or whatever.
Right.
Yeah, Michael, nothing on there? Really? Oh, I guess they want you to just know this like me, right? Okay. Well, I'll help you out here, okay?
I mean,
We-
you can do it with the half angle formula.
Yeah, you can do it with half angles and everything else, right?
Couldn't you
So-
in theory do cosine times cosine and then do like integration by
By parts, cosine, yeah, that's going to be fun, right?
You could.
Yeah.
It'd be ugly. I would
Yeah,
not.
you do that then.
I would look for an identity, okay? So this one right here, they say the following, okay? They say 2 cosine squared x minus 1 equals cosine of 2x. It's a double angle, right?
I'm just gonna trust it.
Wait,
Michael and Ryan?
how complicated is the reasoning for that?
Complicated?
Yeah, like how intricate is the explanation for that?
Well, with the cosine squared x, there's 3 of them, if I remember right, on the sheet.
Circle?
On the circle, yeah. There's 3 identities when it comes to this one. That's the hardest part.
So
in my
you're just supposed to know
Yeah, I guess they want you just to,
that? Okay.
you know, your identities, right? Because then you can't integrate this beast, right?
So now we have like 3.
Watch me with that thing.
There's I remember there's 3 for cosine squared x, and yes, there's cosine sine squared x minus cosine squared x equals something, or there's sine squared x plus cosine x equals 1. Then I can manipulate that. Cosine squared x equals 1 minus the sine squared x. And then I got the double angles, right? Because I want to use, instead of the powers, I want to get that to a singular power, right? That's the whole thing. Unfortunately, it doesn't have it on there. Michael's like, nope, it's not there.
Yeah.
So, like Eileen's looking for, there's a trig table and so on, right? And this is one of them if I'm right. Yes, no?
Probably.
Probably, right? Okay, she said probably. So, here we go. We're going to move this and make this plus 1 here, plus 1 there, right? She's like, yeah, whatever. So now I got 2 cosine squared x equals cos 2x plus 1, right? With me so far? You can't see it, okay? I'll magnify.
Yeah, right here.
Okay, so far? So remember what they give us. They gave us this 4 guy, right? I'll do the 4 in a second, okay? So just say to yourself, we got cosine squared x, right?
Yeah.
Right here?
So cosine squared x, and there's a 2 there, right?
It is on here, Mr.
It is
It's
on
just
there?
hard to see.
Hallelujah. Praise the Lord. Okay? So it is there. So now I can manipulate this. Not bad?
Yeah.
Well, we have, ladies and gentlemen, what? Well, if I got this guy right here, I need to double it, yes? Because that's a 2. That's 2 here. And I got to double whatever I have. So this becomes instead,
Just take 2 of them outside the integral. leave
you
the other
wish,
2
you
in.
wish, right? So you're going to get 4 cosine squared x. We're going to replace it with what? This is what we're going to replace it with, okay? 2 cosine 2x plus 2.
Yep.
That
Okay.
goes right inside here with the 4, okay? All right? So here we go. This side's beautiful, okay? Ooh, can't see it. This side's beautiful, okay? We're going to replace that 4 cosine squared x with this guy right here.
Yeah.
Well, you got a 10-banger, right? They want, blood.
Yeah.
Obviously.
Obviously, right? So integral, right? Because we haven't done nothing yet, right? I'll put parentheses there. Replace 4 cosine squared x. I can put him back, right? So we have to reverse what Ms. Abear did, which is fine, which he did, but now we're going to put it back to say, oh, what do I replace this power with? With this guy right here.
Alright.
2 cosine 2x plus 2. Don't forget my dx. Okay? Dx this, right? Not dmx, dx. Okay? You guys probably don't even know dx.
So what's the integral of cosine 2x?
Ah, now, great question. Now, you just look at this guy right here, right?
Why don't we factor out a 2 and make it cosine 2x plus 1, and then we take the 2
You
outside
help
the
out
integral,
2x.
it makes it easier.
You could,
I think I just cleaned it up
you
better.
can, but it will clean up either way. Doesn't matter.
Yeah, but this is easier to integrate because we
You can take a 2 out, fine, it won't matter. You want me to do that?
Yes, please.
All right, just do it. Okay.
What do you guys think?
2, we'll do it.
That's
2
what I
here,
I
right?
don't know.
Cosine 2x plus 1. The Ryan method. dx. All right, now I integrate cosine of 2x, right? What's the integral of cosine?
Son.
Sine of 2x, right?
Isn't the integral?
Over what?
Isn't it negative?
The
No.
over 2?
Over 2. Now we got Ryan's 2 on the outside here, right?
Why is it over? Oh, okay.
Right? Now this one's easy. What's the integral of just dx, right?
Okay.
Just x. Plus the secret sauce. What's the secret sauce?
Okay. I mean, C.
C or K. It doesn't matter. You can say, I would give you credit for either one, okay? Cleaning it up. We got what? These cross out. Sine of 2x plus the x plus the secret sauce. Not bad? Says me, right? Well, don't forget this other stuff over here.
Wait.
Natural log, yes.
It was 2 times the entire integral of cosine 2x plus
So I have to
1.
bring the 2 here.
Yeah.
Yeah, that's right.
So x over.
2x hit 2x there.
Isn't it x over? Or, yeah, okay.
2x. That's a 2x. She's right. I didn't distribute, okay? Because you made me pull it out. It's your fault. You made me pull out the 2. I just said to multiply by 2 afterward, right? All right, I'm going to stop there. How's that? Are we okay?
Yeah.
Is a little... There's nothing wrong with Ryan's method. It's just that he threw me a curveball and I've been throwing you fastballs, right? And so I forgot to multiply by 2, right? It is x, and then, remember this whole expression is multiplied by 2? I did it for here, I just didn't do it there. All right? It's 5 minutes and now we're done.
Yeah.
Yeah, okay. Now you just plug in what? Just for fun, right? Let's see here.
Things to get C.
I would know. So